So continuing, we say f of c is called local minimum value. Local. If f of c is less equals fx for x near c. Okay, we are not requiring any more throughout the domain. Just near c, fc is smaller than or less than. So that makes it local minimum. All right. Likewise, local maximum means you have to be greater equals. So here is the formal definition. The number f of c is a local maximum value of f if f of c is greater equals fx when x is near c. Likewise, the number fc is a local minimum value, local, of f if f of c is less equals fx. Okay, minimum means you have to be less than or equal to when x is near c. In definition 2 elsewhere, we say that something is true near C. We mean that it is true on some open interval. Now, this is a technical term. Near C can also be, instead of saying near C, some authors say in a neighborhood of C. So, they use open interval around C. All right. Now, here is figure 3. Look at the wave. Yeah, so at 4 you have some kind of minimum, right? But it is not absolute minimum because absolute minimum is here. So this is some kind of minimum. It is not absolute minimum, it is local minimum. In a neighborhood of 4 or near 4, this is a minimum. All right. Likewise, here we have some kind of maximum. It's not absolute maximum because look, that is even higher. Here though, this is a local maximum and that's near 8. This is a local maximum. This point, it is actually absolute minimum as well as local minimum. So if you have an absolute minimum, it's automatically a local minimum, but a local minimum does not mean it's an absolute minimum. All right. So I hope you have an idea. Difference between local versus absolute. Absolute means it has to be minimum among all of them. Local means near, in a small neighborhood. All right. Next slide. It's not the absolute minimum. So the same argument that I gave you before. Okay. There is a difference between absolute minimum and local minimum. So absolute minimum means you have to look at the entire domain. But if you're looking at smaller values near x, then it is a local minimum. All right. Here we go. Now, here is a cosine function. All right. Now, it has this point, and so on. They are both local as well as absolute because see, the maximum you go is here, then you come down, then you go up to the same maximum. So, this height is absolute maximum as well as local maximum. All right. Likewise, this height, -1, is an absolute minimum as well as a local minimum. So what are they saying here? Fx equals cosine x takes on local and absolute maximum value of 1 infinitely many times. Of course, at 0 you get 1, and again at 2 pi you get 1, again at 4 pi you get 1, again at 6 pi you get 1. Likewise on the negative side, negative 2 pi you'll get 1, negative 4 pi you get 1, negative 6 pi you get 1, and so on. So even pi you get 1. All right. Now odd pi you get -1. Look at that. Pi you get -1. 3 pi you get -1. 5 pi you'll get negative. Likewise on the negative side. So 2n plus 1, that's how you detect odd numbers. When n is 0, you get 1. When n is 1, you get 3. When n is 2, you get 5, and so on. Whereas 2 times a number is always even. 2 times a number and one more is always odd. So odd numbers fetch you minimum values, even pies fetch you maximum values. All right. So before continuing, I'll stop my video here. Until next.